It's trying. There we go. Hey there. Welcome, everybody, to Astronomy Daily Live. It is the 14th of January, 2019, and it's 2 hours UTC. It's the wee hours. It's the wee hours of January 14th, 2019. So welcome, everybody. Come on in. Come on in. I'm going to grab my chat here like I sometimes do. There we go. All right, very cool. Hope everybody's doing well out there. So this is a daily live stream where we just sort of sit back, we grab our consumables of choice. I've got a little bit of coffee left here, and I've got the hydrogen hydroxide. I am like set, right? I'm like set. I just don't have to go anywhere now because I am set. So yeah, so hope everybody's doing well. So, you know, we come together each and every day, practically each and every other, practically each day, and sit back and just sort of casually, fun, chit chat about all things astronomy and space and science and all kinds of other nerdy things. This is, definitely, if you want to nerd out, this is the place. So yeah, glad everybody can be here once again. It's really great, having everybody here, and there are some regulars and there are some not so regulars, and that's part of the cool thing I think about this daily live stream is that if you can, come on in, and if that's every single day, that's awesome. If it's every other day, every week, every month, every year, cool. You're extremely welcome here, extremely welcome. And, this is a place for everyone. So, like if you're brand new to astronomy, or, if you've been in it for a while, maybe you have a telescope. And if you're a pro, right, you've been in it for your entire life. This is the place to be, because we definitely like to talk about all things astronomy, not just the headlines, and not just my little project or your little project or everything else. Try to cover as much as we possibly can, and it can be casual because it's every single day. So there's no rush. There's no I've got to try to pack in as much information as I possibly can, and I, for one, am definitely not going to try to teach anything or communicate things. I'm just going to share passion. And some of that is, a little bit of knowledge, a little bit of experience, and a whole lot of fun, right? I can definitely say that my career in astronomy has been really fun, and that's intentional too, because a lot of professional astronomers actually spend a lot of their time not doing astronomy at all. They're doing paperwork. They're trying to deal with students and all the administration. And when I was a student, I saw all of that, and I'm like, wow, I've got to figure out a way to not do that. And I have. So that is great fun. Andy Cowley, hey, nice to see you over there in the chat. Hope all is well with you. Cheers. So on the panel is Tom. Hey, what's going on over there?
Not too much tonight. Still kind of cloudy here, so no stargazing for me, I guess. But
yeah,
hopefully it'll clear up. I did find a couple of news items. Could go over those later if you want.
Cool. Yes, absolutely. What I don't think I've ever asked Tom. What kind of telescope or binoculars? What have you got?
I don't have a telescope. Well, I bought one of those Galileo scopes. It was a charity thing going on, and they gave the money to some charity. I bought one of those, put it together, looked through it. You can't really see a lot with it, but you can. I mean, you can see the moon and things like that. I did buy a pair of binoculars, and I've used those a little bit, but they're kind of heavy. And even though I put them on a tripod, I still kind of awkward wrangling them. So I'm thinking of either getting some smaller binoculars or a small scope. That's about all I've got.
Very cool. Very, very cool. It's amazing what just, like a small pair of binoculars, can do for you. You get out a little bit dark, and it's absolutely fantastic. But yeah, the bigger ones. What size do you have?
I went pretty big. They're 25 by 100.
Ooh, okay, big eyes.
Yeah, and I bought a heavy duty tripod with them, so I can get the binoculars to settle down, but they're still kind of heavy to haul around and set up and all that.
Yeah, those are big too, right? They're probably
that's
like
about
that
right.
or so.
Yeah.
Yeah, cool, nice. So 25 by 100, that's 100 millimeter. So yeah, that's bigger, than most small refracting telescopes, right? So yeah, that'll do you good. And 25x, that's a pretty reasonable magnification. That's getting a little high, so your field of view is probably pretty narrow. Can you get the whole moon in there?
Yeah, I used them for the total we had in September a couple years ago, and you could see the whole thing. So they were really good for that.
Sweet. Yeah, once you sort of, get used to that, get used to the setup and everything, you're probably really going to like those. You're not going to want another telescope because, man, you've got two there.
Yeah, I thought they would be good, and there's nothing wrong with them. Maybe I'm just haven't used them enough to really get the hang of swinging them around and aiming at the right things. And
yeah, and there you might look around, of course, costs, but there are different kinds of binocular mounts that sometimes make it a little bit easier, right? Because you're always having to worry about the tripod legs and all that kind of stuff. And in fact, I've seen some binocular mounts where you actually sit down and forget exactly how it works, but you actually rotate with the binoculars, and so you basically just sort of have to turn yourself up and go up and down, and it's I mean, all these things are a learning curve, all of them, right? There's nothing easy really, but yeah, that I thought was pretty nice, because you can sit down, it's sort of relaxed, and you got these big lenses and everything, and so yeah, I think you're exactly right. I think it's just sort of a matter of working with what you've got, and that's exactly the same thing that I'm doing here, right? You sort of work with what you've got, and you get used to it after a while, and weeks or months might go by, and then all of a sudden it's like, why was this so hard to use? Why was this so difficult, right? So it's just a learning curve, probably.
All right, I won't give up on them yet.
Don't give up. That is one of the things that I do talk about a lot, right? Is that you got to be a little bit stubborn, but you got to be patient with yourself, and if you really want it, you'll do it. I mean, that. So so yeah, stick to it. You've got some nice optics there, right? Those are pretty sizable, and I mean, with that pair of binoculars, you can see all the Messier objects. Easy, super easy. So you got to be on a dark site, but besides that, you can see all the Messiers with that. Easy. So yeah, stick to it. I know you will anyway. So all right. Well, cool. Bobby, what's going on?
Hey, I was like watching CNN earlier and finding out that the federal workers are getting a little bit livid about what Trump's doing.
Yeah, well, like we were saying, sort of in the pre-show, that how this is supposed to work like this, right? The politicians listen to us. We sort of tell them, what to do, what not to do, and they're supposed to do it. They're supposed to consider it, right? Because we've sort of chosen them, to represent us, and so they can listen to us and sort of consider whether they want to do what we say or not. Hopefully that's what's going on. Probably not. but so yeah, if the population starts to say, hey, we want it like this, the politicians are supposed to follow that. So we'll see. Yeah, we'll see. It's this will be resolved, I hope, and one way or another. So we'll see. We'll see. But yeah,
As mentioned before, it's a stalemate.
Stalemate. All right. Well, watch that news in small doses, right? Small doses. You don't want, to take too much of that, because the side effects are just not very nice at all. So just little tiny bites of that stuff. All right. Well, cool. I'm gonna look at my chat again because I passed that up. Andy is there. Space TV. Hey, welcome. And look at that. Nightbot got the weather for Liverpool. Very cool. Very cool. However, Space TV says that there are no clouds. So I always like to hear those kinds of things.
I also did the my weather as well.
Yeah. I see that. So yeah, being a scientist, I always like to compare things, right? It's like, okay, Nightbot is sort of grabbing its weather thing from somewhere. I'm actually not sure where it's doing that at all. And it's saying that, Liverpool right now is mostly cloudy. But Space TV is reporting that he's not seeing any clouds. So kind of interesting there. Kind of interesting. Let's see. What about you? Do you think the conditions are fair where you are, Bobby?
I don't know. I just usually don't check. Usually don't go outside at night.
Oh, no location provided. Ha ha.
Derp. Dummy.
That? Here we go. Mostly cloudy. Yes, it is mostly cloudy here, for sure. Clouds and clouds and clouds. But that's okay. This time of year, that's to be expected. In another month or so.
Winner chicken there when it comes to humidity. You just have to try its humidity.
Yeah. Very true.
But you always complain about high humidity.
Well, of course, I don't want, drops falling off of my telescope. That's That's no good. That's no good. Plus, I'm supposed to be in the desert. It's like, huh? So, all right, well, cool. Well, as I said yesterday, I decided, to sort of switch gears um, today and get into some music. And what I decided to do was actually go back into my project, which I call data music, commonly, I guess, more and more commonly called sonification, which I suppose that's that's as good a term as any. It's the idea that you can take data, any kind of data, in fact, and turn it into sound. And so this is a thing that I've been doing for probably about 5 or 6 years now or so. And there are some real subtle obstacles that must be overcome in order to make that sound, those audio sounds sound very, very nice, right? It's not just sort of cobbling together things. It literally has taken me years and years and years to figure out many of the subtleties involved with that, and to this day, I sort of continue to try to improve things. But today, I went
that's
over.
not how it works, Andy.
Yeah, you got to do like an exclamation point, and then my weather all in lowercase, and then try that postal code. See if that works. So yeah. Today, what I did, I actually got up and it's like, okay, I'm going to try this. I went over to GAIA and I just grabbed a random field of stars, 1 square degree in size, and I said, you know what? I'm going to take the proper motions, right? The motions of the stars, what they appear to be moving to us, and I'm going to take those velocities, which are in milliarc seconds per year, and I'm going to go ahead and convert that to a audio frequency, and then I can take like 100 stars and add up all the frequencies together, and I wonder what that's going to sound like, right? And so took some code, had to modify it a little bit, of course, but coming up with some, I guess, some relatively interesting sounds. I think what I'm going to do is I've got sort of two drones, as they call it, right now, that I'm probably going to post. I guess I'll probably put them over on my Bandcamp account. And so when I do that, I'll probably tweet it out. I'll probably put the links over on the Discord server, and you all can listen to it and probably just get a good laugh at it, because I'm not particularly interested in droning. That's sort of a one aspect of sort of the ambient sound scene, is just these drones, and they can be interesting. I've never really found them incredibly interesting. They are relatively nice, to have in the background, as long as they aren't, too busy, and as long as they aren't, too hard on the ears. There we go. So Gosport, is that is that a valid location? Did that actually work? We will see. We will see. So yeah, I've been having a little bit of fun doing that today. I think probably what I'll do once I get something that I sort of like, I might try to make a video with it too. You know, some kind of visual thing. You know, maybe just showing the stars moving as the sound goes or something like that. I'm not exactly sure. Oh, cool. Well, good. I'm glad that worked, Andy. Nice. It's always nice when Nightbot behaves and does the right thing. So, but yeah, it's this whole concept of data music, what I call that is really it's a very, very, very broad thing. You know, I mean, you can literally use any data. You know, it doesn't have to be astronomical at all. It can literally be anything at all. And it's kind of interesting, because what you end up doing when you listen to these sounds is you're actually hearing relationships, and you're hearing things changing. And I'm still absolutely convinced that this kind of thing does have a valid role to play in research. You know, I mean, scientists really, rely on visual for 99.9% of all the work they do, right? There's words that they're typing or reading. There's pictures. There's plots. It's all visual, right? And there's a lot of information there, right? There's a lot of information there, but there's an equal amount of that kind of thing when you listen to it. And but you have to learn how to listen, right? And like I said, I've been doing this for many years, and I am no good at it at all. Sometimes I can sort of pick out things, but so this to me is still really new. And others who are sort of doing this, and there are a few, they're modifying the sounds to allow themselves, to sort of hear things really well, and they're kind of taking out all the subtleties and everything else, and making it really simplistic, and to a point where the actual representation of the data is almost lost. It's almost lost because those sounds have been modified so much. So, but yeah, for me, this is just sort of an ongoing project. It's kind of fun, and I have absolutely no idea where it's going, what it's leading to, or anything. If nothing else, for me, if I get a little bit of a little bit of fun, a little bit of joy out of it, that's probably good enough. But I'm still hoping that I'm going to be able to find ways, to represent data by sound, and actually have that be one more tool, that the researchers, can grab and use. So we'll see. We'll see. Like I said, I'll probably post, the two drones that I did today, made from GAIA data, and you can give a listen. Definitely like to hear some feedback, and don't hold back, right? I mean, if it's garbage, tell me. I mean, I need to hear that, right? Don't try to be nice or anything. If it's really bad, I'm not expecting it, to be really bad. I don't really expect it to be really good. It's going to be, somewhere in the middle. And, my opinion about it is that it's just kind of like, yeah, it's okay. It's all right. Yeah. Like I said, I don't think it's really bad. I don't think it's really good. But I'm a poor judge of that because I'm the creator, right? And the creator is always super critical and actually a little bit blind, right? Yeah, that kind of feedback is really nice, greatly appreciated. And like I said, any kind of response is much better than no response at all. But yeah, regardless of the response or lack thereof, I'm going to keep working on this thing. There's there's something in my head that just sort of saying, keep working on this, because there's so much more that can be done. For instance, the waveform that I am using to create these sounds is just a simple sine wave, right? Just a simple sine wave. But there are an infinity of waveforms, right? They're sort of the common ones, right? There's a square wave, there's a pulse, there's a sawtooth, many others, right? But what I can actually do, right, is I can take a light curve, right, from like a variable star or like a planet going in front of a star. That light curve I can actually use as a waveform, and then that waveform, substitute that in for my sine wave, and come up with a completely different sound, right? And then on top of that, there's all the concepts of synthesis itself. The ADSR, the attack, decay, sustain, and release, which is sort of the shape of the overall sound, right? And that shape can be used to change the amplitude. It can be used to change the frequency, and it can be used to change. I always forget the third one.
Well, anyway, I'd like to welcome any Cowie to know into my Discord, which is the radio server, and also the ADL server for Cosmic.
Yeah, very cool.
And what's also good that the ADL server is Cosmic's and the radio server is actually mine.
Yeah. Yes. And how's the server going over there? Is it pretty busy? Is it getting full?
It's like getting there. We're getting some good activity.
Cool. Nice. What is that image all about you choose to use on your live stream page on Space TV? The image that I choose to use on my live stream page. The image that I used. What? I'm not quite sure which image you're talking about, Space TV.
Is that the cartoon like woman looking up thing?
Oh, yeah. You're talking about the Fool. The Fool, yes. Well, if that's what he's talking about, yeah, my what is that called? Little icon. That is the Fool, right? Lots of dots. Oh, yes. Space TV, yeah. You asked me to make that when I first got on your system, and that image is an image of Messier 37 taken from Gaia, and it's all I've done. I haven't looked at that in a long time. It's all I've done is just, taken all the stars and just, connected all the dots. That's all I've done.
I think
put some color in there.
I think Space TV, you're on Cosmic server. You're like a radio person, and I provided a link to my server for the radio people.
Yeah, definitely jump onto both. Definitely jump onto both. But yeah, my little what's that called? I forget what it's called. Some kind of icon or something. Yeah, that's actually the Fool, right? So I greatly encourage you to check out the Fool, and you definitely when you understand that, you'll definitely be able to peer into this head a little bit more, because yeah, I greatly respect the Fool, and I definitely wish to be as much like that as I possibly can. So yeah, check that out too. But yeah, the Space TV thing, at least, that I believe is M37, taken from Gaia. And in fact, what I was going to do tonight was actually go over to Gaia and look at some things. And I think M37 in the vicinity of that cluster is actually probably a nice place to go, because we can do some simple looking around, seeing if we can pick out which stars are which stars are part of the cluster, which stars aren't. We can actually look at the parallax and see like how far away they are. We can do some 3D plots. I can also make a stereoscopic image, the left and right, and put it up on the screen and see if you can see the actual 3D thing too. So I think we should do that for M37. Yep, lots of dots with lines between them. That's it. Yeah. All right. Well, cool. Let's do that. So, of course, the first thing that we have to do is we have to go over to Gaia and actually grab all the data. So let's go ahead and do that.
It's supposed to be like in 2020 or 2021, 22 is where we're going to get the third and final data release.
I think there's a third data release, that they're collecting the data for now. And yeah, I think you're right. I think it's like 2021 or 22. I'm not exactly sure. And then I think there's going to be and I think there's going to be a fourth data release as well. So just
data release 4.
Yeah. So data release 2 has got everybody just hyperventilating, right? Because it's so awesome, right? I was actually the other night I was watching the show Connections. James Burke. Is it James Burke? He did a great series. I think it was in like the late 70s or so. But he actually showed a star list made by Ptolemy back in, I don't remember, like 600 BC or something like that. And it was like a 1,022 stars, the positions and brightnesses of 1,022 stars in the sky. And that probably wasn't the first star catalog, but it was a very, very early one, very, very early, right? Well, now, right, GAIA Data Release 2 has about 1.8 billion star locations, and not only their locations, but how they're moving, how far away they are, their brightnesses, their sort of rough colors. They looked at these stars, with a blue filter and a red filter, and so you can sort of get an idea of the color that way. Temperatures. Actually, well, look here. There's a ton of parameters, that you can actually grab. So let me get that set up here. I was over there before, so okay, here we go. So I will share my screen, and we'll go over and grab some M37 data, and then I'll use GNU Plot, the greatest data plotter in the universe. Just my opinion, of course. All right, so here we go. So this is isn't the main page. I've already gone into search here, and what we're going to do in this case is we're going to search by name, so I don't have to look up the coordinates or anything, because GAIA will actually go over to Simbad, right, and grab the coordinates that way. So it's all we have to do is do Messier 37 like that, and see it here. I'm going to zoom in a little bit so you all can see a little better. See, it says Messier 37 resolved, and it's green, right? Which means we are good. I think we can probably choose. Yeah, we can choose too, but usually don't have to do that. Now, this cluster is pretty big, so I'm thinking that I want to have a radius of about, I don't know, let's go really crazy and do a radius of 1 degree. Okay, so that's a diameter of 2 degrees, right? So that's like 16 times the area of the moon. So that's going to be a big list. But yeah, I mean, it's here. We might as well grab it all, right? So what we're doing, of course, here is we're sort of, constructing what's called a query. And of course, we'll see the text of that query on the next screen. But one of the conditions that I like to add, at least, is a limiting magnitude, right? So in this case, I've chosen the G mean magnitude. And G, in this case, is that broad filter, that covers pretty much the entire visible part of the spectrum. And let's set this to, I think that Gaia goes down to maybe 22nd or so, but let's set it to about like 20. Okay, so what this is saying is that to grab all stars that have a magnitude that is less than 20. And of course, the magnitude scale is sort of, upside down in that the smaller numbers mean brighter star. So 20 is sort of, the faintest that we're going to go. And then here's all the data that we can grab, right? And there's just this insane amount of stuff. This is sort of the default. I think the actual default has the proper motions turned off, but I like to look at those. So we're going to get a source ID. We're going to get a right ascension. Right ascension error, do we need that? Yeah, probably not, but whatever. Declination error. Parallax, that's a nice thing, because that sort of indicates a distance. It's not exactly a distance, but it's a pretty good indication of a distance. Proper motion, which of course is how these stars seem to be moving in the sky. Let's see, there's all kinds of other things here. I'm not quite sure what the cores are. Correlation. Oh, okay, cool. So correlation between declination and parallax. Never really looked at any of those. Probably should at some point. Correlation between right ascension and declination on proper motions. That's kind of interesting. So all the astrometric stuff, which has to do with measurements of positions. Let's see, do I have all these in here? I'm going to zoom out just one little step so we can squeeze all these in here. Let's see. So yeah, we can either look at the fluxes, which is the actual counts, calibrated counts as seen by the CCD, or we can look at the magnitude. They can calculate the magnitudes. Well, let's just stick to the magnitudes here. That's just fine. Let's see. We've got the mean magnitude for G, and then we've got the blue and the red magnitudes too, if you ever want those. Let's see. We've got, so this is just the blue magnitude minus the red magnitude. I'm just going to choose the defaults here for the time being. Radial velocity is how much this object, the particular object, is either moving towards us or away from us. Let's see. We'll see if it's a variable star or not. L and B are the galactic coordinates. Ecliptic coordinates. Temperature, that's kind of a nice thing to know. AG is the extinction, so that's sort of a measure of how much stuff is between us and it, and that's why parallax isn't always a great way of knowing distance. You also have to know things about extinction. Let's see, flame flags. I'm not quite sure what that is. Radius value, if they have a measurement of the radius of the stars, that's kind of cool. All right, well, I think we're going to go with this. Okay, and I'm pretty sure, you know, we were talking about data release 3 and data release 4. I'm pretty sure, you know, that data release 3 is not only probably going to have more stars in it, but there may be even more parameters here. So data release 2, of course, added like the blue and the red magnitudes here. Data release 1 only had G. So yeah, you know, they may be adding more data and more parameters. But, you know, as it is, everybody is just hyperventilating about all this data, right? I mean, I am. So, all right, well, let's go to the next page, right, where we can actually show, you know, the query. And this is just a standard database query. The only thing that I'm going to change here is I don't want to just look at the top 500. I want to look at them all. And I don't care how many there are. So here's the whole thing, right? I mean, it's just going to grab all the parameters that we've selected, right? Under certain conditions, right? It has to be at a particular position in the sky, right? And that's what this is. And I guess again here, and the G magnitude has to be less than 20. That's it. That's all we're going to do. So let's submit this query and see how many objects we get. My guess, let's see, this is a 2-degree diameter circle in a very, very rich part of, you know, the Milky Way, right? We're going right through the constellation Auriga, which is let's see, I guess north of Orion, but, you know, the Milky Way is right there, right? So there's going to be just a ton of faint stars, and, you know, quite a few bright stars too. So I wouldn't be surprised if there were at least several thousand stars found here. So let's do it. Bam. Might take a little while. Maybe tens of thousands of stars. I don't know. Wow. Well, okay, huh? So that's 111,000 stars. Now, do I want to work with that many? Yeah, I don't think so. I think what I'm going to do, because I think I want to keep my limiting magnitude to 20. Let's go back and let's change this to half a degree. I think we can do that. Half a degree is also 30 arc minutes. So I'm going to have to do this top 500 again, like that, because yeah, that's, you know, that's a bit much. So let's see. So now we've reduced the size of the circle by a factor of 4, right, in area. So probably this number should go down by about a factor of 4 as well, which is still going to be an insane amount, but you know, slightly more manageable. So let's see. Should be pretty linear, I think. Yeah. So 30,000 stars. Can we handle that? Yeah, I think we can handle that. That's not too bad.
I'd like to welcome Chris Elliott from Elliott Astro Imaging in the chat.
Hey there, Chris. Nice to see you. We're looking at some GAIA data tonight. I just did a query for the area around M37, and I am downloading all this information about 30,000 stars. So that just downloaded. I don't know. Let's see. So where should we do this? Let's do it. Let's do it here. I'll make this really, really big. And I'm going to make it a little bigger. Zoom in. Yeah. Okay. So I'm going to go over to my live thing, and I'm going to make a new directory just for this one, like that, January 14th, 0104, 01014. There we go. All right, so let's move this thing over here. So let's just call it M37, like that. And we can.
And is it true this is your 1-year anniversary of Astronomy Daily Live? I don't think you ever mentioned it.
Yeah, wow, I think it is. Yes, I think I started this one year ago today. So woohoo, yay! Very, very cool. Yeah, hey, you know, if it's that easy, yeah, I'll be doing this for a long time.
Well, happy anniversary, Cosmic.
Yeah, thank you. Thank you. Yeah, you know, like I said, I don't pay attention to these things. So yeah, very, very cool. Thanks for pointing that out. Yay. Well, you know, suits me really, really well, you know, to be looking at one of my favorite objects in the sky on this anniversary. So yay. All right, there it all is, just a bunch of numbers. I'm going to get rid of this first row just so GNU plot doesn't have a fit. But, you know, as you can see, this is just a comma separated table. And did I maximize this? I did. So yeah, you know, each thing here, right, it just corresponds to each thing here, right? So here's the source ID, here's the source ID, here's the right ascension, here's the right ascension, here's the right ascension error, right ascension error, on and on and on, right? We got everything here, everything that we selected. So, all right, I'm gonna make this big again, like that. And let's just plot this thing up. It's gonna be a busy plot, but let's do it anyway. Probably bring the old machine to its knees. Okay, the first thing I got to do in GNU plot is I've got to tell it that every column is separated by a comma. So I do that like that.
It doesn't save it as a default when you do commas?
No, each time that I come in here, I have to do that. There's probably a way, you know, to set that, but yeah, you know, I'm you know, I like to make things hard if I can. So okay, so let's just do RA, dec, and magnitude, all right, brightness, which is this one, all right. So GNU plot starts at column 1, right, as opposed to everything else in Linux and C and everything else starts at 0. GNU plot starts at 1. So that's probably my only gripe about GNU plot, and there's probably a way, you know, to change that too. So let's see, column 1, column 2 is right ascension, column 4 is declination, and then I'm going to make the magnitude what's called a variable. So I think we set this to 20th, right, as our limited magnitude. So because things are, you know, are reversed, this one, I just do, you know, some simple math here, and this column is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So column 10 is the magnitude. Let's just do that for now. So that is going to be my point size. It's just a variable, depending on what that number is. It does a little bit of math, right? Takes 20, subtracts that from it, and then multiplies that whole thing by 0.15, and that's going to be the size of my little dot, which for faint stars, the point size is going to be big or small, and for bright stars, the point size is going to be big. Points, point type 7 means a circle. We'll make it black, and point size is going to be variable. So this is probably going to be a pretty full screen. There were 30,000 stars, but let's take a look. Yeah, that's a pretty full screen there. But you can see already that there's a concentration here, right? Which means we got it. I'm going to make this a little bigger. Poor thing, having to work so hard. Okay, let's make these. Try to make that square. Now, the other thing, of course, is that the RA is going from small to big. So, but a smaller RA is actually west, and that is east. So I like to flip those around. And I'm also going to make this multiplier a little bit smaller too. So, oh, I didn't look and see what my so 88.8 to 87.4. 88.8 to 87.4, like that. And let's make this 0.05 and see if we can pick out individual stars. So yeah, there's a couple of stars there, but we definitely have a cluster, right? We have a concentration of stars here right in the middle. And of course, this radius right here is 1/2 of a degree, right? So from here to here is the diameter of the moon, right? The moon would be about that size or so. So 30,000 stars, that's quite a few stars in there for sure. Let's see. Now, there's lots of ways that we could go from here. It's kind of hard to tell, right, which stars are actually part of the cluster and which ones aren't. I mean, some of these are pretty easy. Let's actually zoom in a little bit here. Let's go from 88.3 to 87.8. 88.3 to 80.
Area, it's going to be 3 units in May 10. That's awesome.
Very cool. 87.8. Did I do that right? 88.3 to 87.8. Sorry. 88.3 to 87.8. We might have to change the deck too, because now it's going to look kind of funny. Let's see. That's from 88.3 to 87.8. That's that is that half a degree, right? 0.8 plus 0.5 is 0.3, right? Yeah, so that's half a degree. Let's do half a degree in deck too, so we're nice and square here. So let's go from 0.3 to 0.8. 32.3 to 32.8.
And later, Andy.
3. Thanks, Andy, for coming in. Okay, so now we got a nice square field there, and I can actually make this.
And cool, Space TV. Thanks for joining.
Yeah, thanks for coming in, Space TV. Yeah. All right, so there we are. We definitely have a concentration of stars, but like I was saying, some of these, okay, this one's probably a member, that one's probably a member, that one's probably a member, but what about that one, or that one, or this one? How do we know, right? Well, one of the characteristics of a cluster is that all these stars are not only, sort of in the same place in space, but they're also moving in sort of the same way. Well, we went over and grabbed the proper motion data, so we can actually plot that, right? We can put the right ascension proper motion on the x-axis and the declination proper motion on the y-axis, and look at a different kind of plot, right? I mean, instead of looking at a position plot, we can look at a velocity plot for all these stars. And the theory goes, right, that all the stars that are actually part of the cluster should more or less be moving in the same way. So we should see a clump of stars that are all, basically have the same motion in the sky. So let's do that. Let's take a look at the proper motion ones. Which, oh, okay, I should have gone over to this guy and looked. So that's 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? 8 and 9 as opposed to 2 and 4. So 8 and 9. So let's go over here, and we're going to change this a little bit. I'm going to keep the magnitudes, right? Because that's kind of nice to see that. And of course, I'm going to have to get rid of these because we're now looking at velocities and not positions. So let's see if we see a clump. We should. Let's I'm gonna knock this back down. We should see a concentration of stars. Well, we should see at least 2, right? One concentration of stars is probably going to be around 0, 0, but there should be another concentration of stars that we might be able to see. And that's probably all the stars that are part of this cluster. So let's take a look. Bam. Well, we probably have to zoom in a little bit because, wow. So there are some stars that have huge proper motions, right? Absolutely huge. Let's make this a little bit bigger. I'm kind of curious to see. Yeah, see, here's one way out here.
Okay, Cosmic, before you continue, I want to answer Space TV's question about my Discord server. It's
Sure.
For anyone that is more into the world of radio when it comes to AM, FM, shortwave, wideband listening, like BHF, UHF, and it's and so yeah, you was bored, like if you're more of a radio explorer, you can explore about like the AM, the shortwave, the FM, and like any of like BHF, UHF, like the satellites, the FMDX, and amateur bands. So you name it, it's going to be there all throughout the radio spectrum between the HF and the UHF.
Very cool. Very cool. Yeah, the radio people, I have to admit, are probably even more rabid than all the astronomy people. So the astronomers, the amateur astronomers, are pretty.
The answer to that question is yes, Space TV.
Yeah.
It's for anybody that is more in the world of radio.
Yeah. But the radio people are at least on par with the astronomy crowd, and I would say that they probably exceed the astronomy crowd in terms of activity and just being just absolutely rabid about it. So yeah, got to admire them for sure. Anyway. So here's a star way out here that is moving fast, right? Over 300 milliarc seconds per year, right? That's moving really, really fast. So, and there are many others, right? You know, that are moving relatively fast. These are interesting stars, probably nearby. Not necessarily, though. You know, this guy is really faint, right? Remember, the size of the dot shows the brightness of the star. So that's actually a pretty faint star. So, you know, maybe it's a dwarf star that is nearby. So, you know, it's just faint, you know, because it's intrinsically faint, but it is trucking along. And, you know, there's a few others here. And there's a lot of interest in these so-called high proper motion
Okay,
stars.
Space TV, to answer that question about broadcasting yourself, there is, if you scroll down to throughout the rooms list, there's usually like just one voice channel that you can go on by, and maybe if you capture anything throughout the airwaves, you might be able to, will be able to like listen to that and stuff for sure.
Cool. All right, but I think what I'm going to do in this case is I'm going to sort of limit our look to here, because I'm really not seeing too much of a concentration right now. Maybe something over here, but it's hard to tell, right? 0, 0 is right about there, right? So this concentration, even the main one here, is a little bit off of 0, 0. So I think what I'm going to do right off the bat is I'm going to go from -50 to 50 on both axes, so we don't have to worry about all these outliers here. I like the outliers, but I'm sort of looking for something else at the moment. So let's see if we can actually see that little concentration of stars. Well, let's zoom in a little bit more. All right, let's go -20 to 20. I'm starting to see something right here, though. You see how there's a little bit of an extension there? There's a lot of stars here, right? I mean, we're probably chose a few too many. Ah, there we go. Look at that. So there is definitely a concentration of stars here. So let's sort of start zooming in on that, right? And see, you know, now what we're sort of interested in is, you know, are they basically the same brightness, right? Or is there a huge variation, right? So let's go from 0 to 5, and I don't know, maybe 3 to 8, right? I sort of want to keep these square, right? So here's 5, right? 0 to 5 is 5, and then 3 to 8 is also 5. So let's go 0 to 5 on the x-axis, 0 to 5, and we'll go 3 to 8, 3 to 8 on the y-axis. Whoop, did I do that wrong? I must have done something wrong. Let's go back. Oh, haha. -3 to -8. That'll do it every time. And do I want to? I think I want to go -8 to -3, just so we can keep the same there. There we go. Yeah, so that is definitely a concentration in velocity space, right? So all of these guys are moving through space at more or less the same velocity, right? You know, there is a little bit of a spread here, but if I put my cursor right in the middle, I can sort of look and see, you know, the coordinates here, and right in the middle, I'm seeing like 1.9 in right ascension and negative 5.6 in declination. And I got to say, that's probably it. I wonder if we can just do a simple Google search and see if there are any proper motion measurements of Messier 37. Just as a sanity check, right? Not seeing anything. Not seeing anything here. Let's go over to the source. This should tell us, hopefully, M37. One cluster, proper motion. Okay, so this is saying 3.29 in RA and negative 6.84 in DEC. So, and what I'm seeing here, right? So 3.29 would be way over here, and 6.84 would be sort of down here. So, there's a little bit of a discrepancy there. Not quite sure what's going on with that. Let's see if here's another proper motion measurement. Let's see what they say here. Okay, so this one from 2014 has it at 2.08 and negative 6.4. So again, that's pretty close in RA. 6.4 though is like down here. So I have absolutely no explanation for why there would be that kind of a discrepancy. I mean, it's pretty subtle, right? But also, not, I mean, obviously there's a difference there, right? Because I'm seeing about negative 5.6 or so. So, well, I would say, just sort of roughly speaking, that I think we definitely have our cluster members here. Pretty confident with that. Yeah, for sure. All right. Well, that's kind of interesting. Kind of cool. It's nice to be able to look at data like this and see different kinds of concentrations. I didn't really look to see if there were any other ones anywhere. Let's go back and just sort of, oh, that's a little too tight or too wide. Don't really see any other main concentrations. Let's go negative 10 to 10 on both axes and sort of get into the middle of that concentration a little bit more. There does seem to be sort of a large group here, maybe a little bit of a concentration here, right? Maybe a little bit of concentration here. Now remember, this is velocity space, right? This is not position. This is motion in the sky. So you sort of have to, tilt your head sideways a little bit to realize that, right? So these aren't positions of the stars in the sky. These are their motions, and yeah, just looking at it, right? There's some kind of interesting structures here. Let's go negative 5 to 5, and let's go. What would that be? Let's go up to 3, negative 3, negative 8. So 3 to 8, is that no, that's not 5. or 10? I think so. Okay, let's do it. So let's go -5 to 5 here. And we're going to go from positive 0.3 down to positive 3 down to -7. Yeah, that'll give us 10 on both sides. So, you know, I'm just sort of looking around here, and yeah, that concentration, it's kind of hard to tell. It's fun to do this, though, just sort of off the cuff. So I just increase the size of the stars so we can, that allows our brain to sort of average things a little bit more. There is definitely, you know, a large number of stars that are sort of out here, right? I mean, it's like a little bulge. But yeah, I'm not really seeing much of anything else. There's some interesting structures here, maybe. Probably it looks like there's a concentration there. Let's go right in between these sizes here. Yeah, kind of hard to tell. Kind of hard to tell. We'd have to do a different kind of analysis to really get a good sense of that. I just sort of like to see it. See, you know, some interesting structures in here, right? There's a little, it looks like, you know, there's a little bit of a gap here, a little bit of a gap here. But, you know, our brains want to find patterns and you know, want to find things that really aren't there. So you can't, you know, and this is part of the skepticism, right? You really can't trust what you see, because, like I said, I mean, our brains are fine-tuned to look for patterns and things, you know, that look familiar and all that. Now, I mean, this concentration is extremely obvious, right? You know, there's a population of stars in this field of view that are most definitely moving very, very differently than most of the other stars. So this is definitely the cluster, right? For sure, right? But yeah, you know, there's some other interesting things going on here too. Now, I noticed that I'm running a little long, so I think the last thing that I want to do is I want to look at parallax, right? So I'm going to go back to right ascension declination, but then I'm going to add a third axis and look at the parallax, which is a pretty good indication of distance. So let's see which column parallax was in. 1, 2, 3, 4, 5, 6, right? Parallax was in 6, column 6. So let's go back to here, and we're going to go back to right ascension and declination, this one. Okay, and yeah, let's use that one. And I'm going to add a third column, 2, 4, and 6. We'll keep the size of the stars being the magnitudes, and we'll put the parallax on the z-axis. Let's see what happens. Here we go. So now I can sort of rotate this thing around, and as you can see, you know, there's a lot of negatives and there's a lot of positives. Mostly everything, right, is really, really, really close to 0. Really close. But as you can see, there are some stars that have some pretty high parallaxes, right? Almost 10 here. That's pretty cool. Yeah, you know, we should talk about parallax a little bit more. I guess I'm not going to get into it too much now, but let's let's see if we can sort of zoom in on this parallax axis a little bit. Let's go from like let's go from zero to what? Let's go 0 to 4, right? So we're not going to see any of the bigger ones up here, but we will see the lower ones. And this, what this is, right? This is a way of getting a good idea as to how far away these stars are from us, right? The further away they are, the smaller the parallax. So that means that these guys up here are, pretty close to us compared to all these guys here, right? So, and this sort of makes sense, right? There's quite a few bright stars here that are relatively close to us. So, yeah, let's go from 0 to 4. So we'll just sort of cut it off there, and that'll help us peer into that population a little bit more. We're still seeing quite a concentration. But I'm starting to see like a concentration here and a concentration down here. Let's make this a little smaller. The size of the star is a little bit smaller.
Gotta
Ooh,
wait
look at
for
that.
you, Ray.
Oh, look at that. There's a bunch of stars that have the same parallax. Kind of interesting. Let's zoom in even more, right? Let's go 0 to 1, right? That'll sort of include all of those. So very, very small parallax values, but all of those stars, look at that. They're all within like 0.6 and 0.8. And look at the size of the dots. They're all about the same. So my guess is that these stars are also part of the cluster. This is sort of another way of picking those out, because of course, if they're being part of the same cluster, they're all going to be the same distance away from us, and so their parallax are going to be more or less the same, right? But what we're actually seeing here is actually some depth, right? Some of the stars are closer to us, and that would be the higher parallax ones, and some of the stars are further away. So we're actually getting a sense of depth here too. So very, very cool. Let's go a little bit more, and then we should probably end this. I noticed that it's 3:23 UTC. So let's go from 0.4 to 1. So 0.4 to 1. 4 to 1. Maybe we'll do one more plot too. So yeah, for sure, there's a bunch of stars in here that are more or less the same parallax. Let's boost that up to 1. Very cool. Very, very cool. And of course, this position here is, I guess this is declination, right? So let's rotate this around so we can see various things. Yes, this is 3D. Haha. So let's get it so what it looks like in the sky, right? So we're going to go from higher RA and lower deck to higher deck and lower RA. Okay, so this is what this looks like in the sky, right? Like that. M37, right? But now we've added a z-axis, which is the parallax, which is essentially distance. So this is when it gets fun, and I love GNU plot, because we can rotate this thing around and get sort of an idea, right, of the 3D shape of this cluster. So pretty cool. Let's do one more plot really quick. Let's do proper motion RA and DEC versus parallax. So 8, 9, and 6. So let's do this one. And now I'm just getting completely carried away. 8, 9, and 6. So this is going to be velocity and parallax space. Wrap your head around that one. Okay. That should do it. Not exactly sure what this is going to look like. Oh, okay. Yeah, right. So let's do this one instead. -5, 5, and -7 to 3. As you can see, one can spend hours and hours and hours and hours playing with all this stuff. Okay, so this is velocity space along these axes and parallax along that axis. And as you can see, all those stars that are moving together are also sort of the same distance away from us. There's a little bit of a spread, of course, but more or less, those I would say are definitely members of this cluster. Of course, this is how we're looking at it.
That cluster's in the Milky Way, right?
Yes, absolutely. Yeah. Actually, yeah, we might actually have a distance here. 1,383 parsecs. So it's not nearby. 1383 times 3.26. So that's about 4,500 light years away. And if we were actually to take these parallax numbers, right, we could do some simple math and measure the distances ourselves. So very cool, very cool. This is the fun and games that you can have with GAIA, and people are just pouring through this data now. Just they are looking at everything that they possibly can.
Is there an estimate for what percentage of the Milky Way that cluster represents?
Like what percentage of stars? What mass?
Yeah, maybe if you check the chat, you'll probably know more.
Sure. Let me take a look here. Yeah, Space TV. This is a sort of a typical cluster, probably several thousand members. So as a percentage of the number of stars, very, very, very small. Very small. Yeah, I mean, fractions of percent. Yeah. So, seems like a lot here, but nah, not really. Not really. But this is one of my favorite clusters, and with a very nice pair of binoculars, hint hint, or a nice scope. M37 is a beautiful object, fantastic object. Like I said, it's one of my favorites in the sky. So yeah, sort of nice to see it in different ways. I like it. All right, well, I am way over time. I like to keep these things in an hour, and I never ever do. So, but you know, that's always the goal. That's always the goal. It's never going to happen though. So, all right. Well, for now, I think I'm going to get out of here. So take care, everybody. Thanks for coming in. It's, you know, I think this is a lot of fun, sharing a passion, and you know, you're sort of coming along with me with this sort of an exploration of things, and there's just so much to do, and yeah, wow, it's been a year, so that's pretty good. You know, we've gone around the sun once. Nice. That was a long journey. It's a long journey. So yeah, really glad, you know, to be here. You know, the science of astronomy is very wide, very high, very deep. There's so much. There's so much that you know, lifetimes and lifetimes are spent working on these things. So me doing a little live stream each day, you know, for an hour, it's not even a drop in the bucket, right? I mean, just absolutely nothing at all. But it is great fun, and that's what it's all about. So, all right, take care, everybody. Make sure to subscribe if you haven't. Thumbs up if you like. Make some comments. Spread the word. And yeah, most likely I will definitely know more by tomorrow. But most likely the live stream for the 16th is going to be canceled. I'm going to be on the road a little bit. So, but I'm not precisely sure about that yet. So I would say at this point, there's probably a 90% chance. But, you know, phone calls have to be made, and, you know, locations have to be found. So, you know, until we're absolutely sure.
Like your boss never made that final decision yet, huh?
Well, you know, the plan is to go then, but yeah, he needs to, you know, get in contact with, you know, the people, you know, that we're going to see, and you know, so that has to happen first. But yeah, very likely that that is going to happen. But you know, I'll keep you updated with all that. All right, take care, everybody. I will see you on the spin. See you later. Bye.